So with this work, we were able to explore the nasal epithelial cells in incredible granularity. We used a multidisciplinary approach across different institutes of UCL, grew up the nasal epithelial cells here, and we carried out the infection at the Royal Free Hospital. After that, we transferred the cells to the Rain Institute, where they prepared the cells for single-cell RNA sequencing, which was carried out at the Sanger Institute, our collaborators, where they also performed the bioinformatics. In the key findings of this work, we were able to detect specific cell types across the pediatric groups and the elderly groups. Within the pediatric groups, these cell types were more protective against viral infection, whereas in the elderly groups, we discovered cell types that associate with pathogenesis, including fibrosis.
We discovered that children have a high proportion of goblet 2 cells, which showed the highest expression of the ACE2 receptor and TMPRSS2 protease that are necessary for SARS-CoV-2 viral entry. These cells are the target of the viral infection in children, and they readily replicate the virus. However, rather than completing viral replication and creating new virus virions, the goblet 2 cells rapidly stimulate production of interferon and become goblet 2 inflammatory cells. The interferon inhibits the viral replication machinery, and we detected an increase in subgenomic viral RNA. This indicates that incomplete viral replication is occurring, and despite high viral reads, we detected few viral particles in these cells using electron microscopy. We also discovered that older nasal epithelial cells were more susceptible to infection, particularly at 24 hours, where we found a greater proportion of cells showing viral reads compared to the younger cultures. Here we found that viral infection led to epithelial damage and disruption of the epithelial membrane, including increased cell shedding early in infection. This damage led to the recruitment of progenitor basal cells to the apical layer, including migrating basaloid-like cells, which had a gene signature commonly identified within dysfunctional repair pathways. This include increased fermentin, fibronectin, and integrin beta-6 expression, which are normally associated with the development of fibrosis. Overall, this led to a higher production of infectious virus compared to pediatric and adult cultures, and an increase in integrin beta-6 and TMPRSS2 expression in the apical supernatant that may further potentiate infection in these cultures.
This work is important because it's the first time we have been able to define specific cell types that are driving disease severity in the elderly. This means that we might be able to develop drugs that target these specific areas.